Welcome to this demo that introduces our advanced OpenBIM collaboration between ArchiCAD designers and AxisVM structural engineers. In this presentation, you will learn how OpenBIM projects are shared between architects and structural engineers. This demo will show how you can save time and money by implementing the OpenBIM collaboration workflow using Graphisoft ArchiCAD and AxisVM. Let's summarize the main features of the IFC data exchange file format, which is the basis of our OpenBIM workflow solution. IFC describes the precise geometry of a 3D building element. For example, in case of a column, its height, width, and cross-section. In addition to geometry, additional building element properties can be stored. For example, its property material or fire rating, acoustic rating, and the function of the element. IFC provides the user the ability to filter a large database. You can choose to access or display only the data you are interested in. IFC provides the user the ability to use a reference model concept to see and compare models of other disciplines and to see updates of model revisions or proposed revisions. The IFC scheme and code was created by the International Alliance for Interoperability and is open for use by all software developers. For example, ArchiCAD and AxisVM can collaborate not only with the major BIM softwares, but also with local or regional applications using the IFC format. Since the IFC scheme is more than 15 years old, it is a highly refined data format. IFC allows for an easy-to-use interface, such as a one-click model export and import. In addition, the content of the IFC file can also be read by a simple text editor. Although the official language of the IFC standard is English, its interface can be localized, enabling its use worldwide. A word about these applications and their developers. Graphisoft ArchiCAD is a unique building information modeling BIM solution built by architects for architects. Implementing BIM in your everyday design practice means that you will need less time to complete and deliver an architectural project. Also, the design coordination and collaboration processes will be smoother, shorter, and more productive. Civil engineers on 5 continents use AxisVM for the analysis of structures with confidence that their final engineering product will meet the most up-to-date engineering analysis and design requirements. For nearly 25 years, AxisVM has been recognized as the industry standard for building analysis and design software. Today, continuing in the same tradition, AxisVM has evolved into a completely integrated building analysis and design environment. Structural analysis software that is intuitive and graphically driven, so it is exceptionally easy to use. Both ArchiCAD and AxisVM implement the OpenBIM collaboration process. Here is an example of an ArchiCAD design and an AxisVM analysis. First, an overview of the main steps of the Graphisoft ArchiCAD and AxisVM workflow. Let's start with the architectural model. Architects create an initial model version based upon the client's request and the given building site. Architects filter the structural elements by using element classifications, layers, layer combinations, display settings, selection modes, and so on, to prepare the model for export. Of course, the entire project without any filtering could also be exported. The architectural model is exported in IFC format. Engineers receive the architectural model and open it. Engineers define the structural and the analysis model and its details based on the referenced architectural model. Engineers can query the initial profiles and materials defined by the architects. They add loads to the structure and run analysis and design calculations according to the required country standard and material definitions. The proposed structural model, derived from the analysis model, can be exported back to the architects in IFC file format. The architects can either merge the structural model into their current architectural project or open it as a totally new file. Filtering is also available for the import, and imported elements can be placed on given layers. By default, newly imported elements will be protected from modification, in keeping with the reference model concept. Architects may compare two view sets, one of the architectural model and the other of the imported structural model. Architects can query the profiles and materials used by the engineers and modify their project to match the imported reference model, or they can accept imported elements by using them as real ArchiCAD type elements. After review, architects can then export a new IFC file based upon the project's new status as a revised model. The engineer then opens the new architectural model and compares it with the previous architectural model version. Changes can be double-checked by the engineer. Based on this comparison, engineers can make final draft changes in the project. Both engineers and architects can repeat the above described process of model exchange, comparisons, and updates in additional cycles. Finally, the two disciplines make their own or combined documentation. Now let's see the workflow live, starting with architectural modeling. Here you see a 3D view of the entire architectural project in ArchiCAD. The architectural design must be shared in a way that meets the requirements of the receiving party, in our case, the structural engineers using Axis VM. Thus, we want to export only those load-bearing elements necessary for structural engineers. The first step is to deactivate the unneeded layers from the 3D view. To perform a quick and fully automatic element filtering, all elements in the architectural model must be correctly classified with respect to their load-bearing function, type, and position. For instance, let's select this slab and open its settings dialog. Here we can classify its function as either load-bearing or non-load-bearing, depending on the role in the design. Such classifications have a direct effect on the content of the exported IFC file. The load-bearing property is a standard IFC property, interpreted accordingly by all IFC qualified applications. Another important element classification is element type. For instance, this slab was created by the slab tool of ArchiCAD, so its default element type classification is slab. However, its element type classification could also be set to ceiling if it were used to model the suspended ceilings in our project. Finally, we may set the position of the element with respect to the building envelope. For instance, this slab can be classified as an internal or as an external element. Any custom properties can also be created, if required, by the engineers or consultants who work with the exported file. For example, acoustic and fire ratings can be set for every individual element as standard or custom IFC properties. Let's now activate the Partial Structural Display option of ArchiCAD. This feature helps us to display only the elements classified as load-bearing. In the case of composite structural elements, only their core load-bearing element will be displayed. The window and door elements can also be hidden, and only their nominal opening will be displayed, since structural engineers typically require only this. To summarize, all elements in the architectural project model must be appropriately classified. This enables us to filter the architectural model and display only those elements needed by the receiving party. In our case, only the structural load-bearing elements are displayed. And now we will export only these elements for the structural engineers in the IFC file format. We simply use the Save As command in the File menu, then select the IFC file type from the list. We choose the most appropriate IFC translator from the default list of translations. Custom translators can also be created according to the requirements of the receiving party. In our case, let's select the General Translator. Let's briefly review the settings of the selected translator. As you can see, the content of the IFC file can be fine-tuned to export only the necessary elements from the architectural project model. In this case, only the structural elements of the architectural model will be exported, since these are the elements that are necessary for the work of the structural engineers. We can also decide to export the entire project, or only the visible elements, or only some selected elements. Let's save the visible elements only, the load-bearing elements seen in the current 3D view, and send it to the structural engineers who use AccessVM. AccessVM will now be used to perform the structural analysis and check the architectural design. We start by importing the architectural model into AccessVM. AccessVM has enhanced support for all types of IFC files, even IFC2x4 files. We import the IFC file as an architectural model object. This feature makes it possible to manage both the analysis model and an architectural reference model in the same project and environment. Here we can see the reference model. It is used to generate the structural model. We can view the architectural design and use it to model the structure and perform the analysis. There are multiple ways to model in AccessVM. In this demo, we start by converting the architectural objects to analytical objects. Here, we launch the architectural model command, and we convert all of the architectural objects into structural objects. The result is a complete structural design, which can be used for both coordination and analysis. We can view the analysis model and the structural model in the same project and environment. The analytical model is used to perform the analysis and design the structure according to the building code. So first we add additional analytical data, such as loading and supports, to enable the analysis. The structural design model can now be exported using IFC file command save as. The IFC model can now be imported into architectural model used by the architect for further coordination and revised design. Let's switch back to ArchiCAD and compare both of the previously created IFC files, representing different versions of the same structural model. We will do it in one single step. We start the Detect IFC Model Changes command. With this, we will import only the modified, deleted, or new elements from the two versions of the received IFC files. The rest of the elements will not be imported. Start by specifying the first version of the received structural design. Then specify the second version of the structural IFC file. The next step is to filter the two IFC files. There are several filter options available. For example, we can filter the elements by their types, for example, compare only columns, by story, for example, compare only ground floor elements, and etc. The next page of the wizard gives us immediate feedback from ArchiCAD on the number of the new, modified, and deleted elements in the structural IFC file. Here we can specify the layers onto which elements imported from the older version of the IFC file should be placed. Similarly, we can specify the layers onto which elements from the new version of the IFC file should be placed. Finally, let's click the Merge button to proceed. In just a few seconds, ArchiCAD will merge only the detected changes of the received IFC model versions and display the markup tool palette. ArchiCAD's markup tool provides great help in tracking and managing structural changes in the design. As you can see, the imported structural elements are displayed in three different colors. Blue identifies the new elements. Green identifies changed elements. And red identifies deleted elements. In the list of markup entries, we can identify each element individually. We just click any element in the list, then we select it, and finally we zoom in to focus on it. Within the context of a large design model, this feature is extremely useful for architects. In our example, the engineer deleted 8 columns from the upper balcony. In this case, we can use the Delete Entry button to delete any markup entry from the list. The corresponding elements can also be deleted from the project model together with the markup entry. As you can see, Graphisoft ArchiCAD and AccessVM provide a complete, integrated, best-in-class design workflow. ArchiCAD and AccessVM together bridge the different requirements for the BIM models of architects and engineers and puts the open BIM approach into practice, broadening designers' options for genuinely integrated project delivery. The architect made some changes, as you have seen in the architectural project. Now, let's see how AccessVM detects changes between two architectural model revisions. Revision and coordination is an important part of the OpenBIM workflow. To manage changes, the engineer requires a tool to compare projects. Model Update gives the engineer the power and insight over changes and the freedom to accept or ignore them. We update the current model by selecting Update after clicking File, Import. The revised architectural model is compared with the existing reference model to identify what has been changed. So instead of remodeling, we gain time by automatically applying the changes to the current analysis model. The update clearly identifies the changes that have been made to the structure. It appears that the red columns have disappeared. We select the changes we would like to make to the model according to the insight of the architect. This way, Model Update allows us to accept changes made by the architect without losing control over the analysis model. The benefits of OpenBIM are numerous, but all participants will benefit from working with the best-of-breed software solutions in their respective fields, maintaining full control over software upgrades independent from others, greatly reduced coordination errors thanks to workflow-level compatibility, the ability to deliver BIM models that are much easier to use throughout the entire life cycle of the building. Thank you for your time and attention.